Good morning, students. This is Bhavna Sinha, your chemistry teacher, and this is the fourth video for this week. Okay, as you all know, we are discussing p blocked elements, and we are discussing in that also we are discussing group 15 elements. Okay, so here we go. We have discussed some of the important points related to them. Now we are discussing some more important points related to p blocked elements. So for today, the first point is reactivity towards oxygen. The first point is reactivity towards oxygen. That means how do they react with oxygen? What is the meaning? How do they react with oxygen? Okay, so here we go. All group 15 elements form trioxides and pentaoxides. Now what can be the formula of trioxide? You can write N2O3. Okay, N2O5. This is 3 oxide, so trioxide, and this is pentaoxide. Okay, so all the members of group 15, they form trioxides and pentaoxides when they react with oxygen. Now acidic character of oxides decreases and basicity increases down the group. Okay, as you will move from top to bottom in the group, what will happen? The acidic character will decrease, but the basic character will increase. Okay, that means if you are moving from nitrogen to bismuth, the acidic character will decrease and the basic character will increase. Nitrogen will be having more acidic character than bismuth, and nitrogen will be having less basic character than bismuth. Okay, and this is because the size of nitrogen is very small. Okay, if you compare the size of nitrogen with the other members, you will find that the size of nitrogen is very small. Okay, now see another point. It has a strong positive field in a very small area. Since the size of nitrogen is small, that is why it has a strong positive field, because it is limited to a small area as its size is small, and that is why it has a strong positive field, and therefore it attracts the electrons of water OH bond to itself and release H plus ions easily. Okay, it attracts the electrons. This point is very important. It attracts the electrons of water OH bond to itself, and in this way it can release H plus ion easily, and that is why it has more acidic character. Due to the release of this H plus ion only, nitrogen has more acidic character. Okay, as we move down the group, okay, as we are moving from top to bottom in the group, the atomic size increases. You all know why the atomic size increases. Why this atomic size increases? Because number of shell increases. Okay, it increases, number of shell increases, and that is why the atomic size increases. And since the atomic size is increasing, the acidic character of oxide decreases and basicity, or you can say basic character of the oxide increases. The atomic size increases, and due to increase in atomic size, the acidic character decreases, and the same, due to the increase in atomic size, the basic character also increases. That means the atomic size is inversely proportional to acidic character and directly proportional to the basic character. What we can conclude from here? I am writing here, the acidic character is inversely proportional to atomic size. Okay, the acidic character is inversely proportional to atomic size. And one more point we can write here: basic character is directly proportional to atomic size. Okay, so we can conclude these 2 points from this reaction. Now the next one is reactivity towards halogen. How do they show reaction with halogens? How the group 15 elements show reaction with halogen? So here we go. When they are reacting with group 15 elements, that means when the halogens are reacting with group 15 elements, they form trihalides and pentahalides like PCl3, it is trichloride, PCl5, that is pentachloride. So the halogen atoms, they can react with group 15 elements and they can form trihalides and pentahalides. Now trihalides, these are covalent compounds and become ionic down the group with hybridization, pyramidal shape. Okay, covalent compounds means which are formed by the sharing of electrons. What is the meaning of covalent compounds? Covalent compounds means which are formed by the sharing of electrons. So these trihalides are formed by sharing of electrons. Okay, now next point, pentahalides, they are Lewis acids. Okay, they are Lewis acids, it is written here. Why? Because of the presence of vacant d orbital. Okay, why they act as Lewis acids? Due to the presence of vacant d orbitals. The pentahalides act as Lewis acids. Okay, now you can see PCl5 is ionic in solid state and exists as, okay, in PCl5 what happens? There are 3 equatorial bonds. How many equatorial bonds are there? 3 equatorial bonds and 2 axial bonds. Okay, the axial bonds are longer than the equatorial bonds. The axial bonds are longer than the equatorial bonds. And why the axial bonds are longer than the equatorial bonds? Because of greater repulsion from equatorial bond. Okay, since there is greater repulsion from the equatorial bonds, that is why the axial bonds are longer than equatorial bonds. In PCl5, how many equatorial bonds are present? 3 equatorial bonds are present. And how many axial bonds are present? How many axial bonds are present? 2 axial bonds are present. And this PCl5 is ionic in solid state. Okay, PCl5 is ionic in solid state. So the group 15 elements, they form 2 types of halides. One is trihalide, okay, and one is pentahalide. And I have given you example of trihalide is PCl3. And what is the example of pentahalide? It is PCl5. So in this way the group 15 elements, they react with halogen atoms. Okay students, rest we will discuss in the next class. Thank you.